Okay, so I'm Anteo. Yeah, I'm working as an iOS engineer for around 6 years now, and I will walk you through uh, basically a way how to structure your code so that you can implement your design in Figma, for example, that you get from designers more efficiently and um, better, basically. Um, okay, let's start. So first, what is a design system? It's a collection of reusable UI components. It ensures consistent design and user experience across the app. And it includes color palette, typography, iconography, spacing, layout, and of course the interaction and motion as well. Okay, so how 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 we want to show this? I wanted to basically the idea is that we try to implement some component that is non-existing in SwiftUI and see how we would do that. So for that, there are many Android people here, so I choose something from Android. Uh, it's called split button. We don't have that in iOS. And it looks something like this. So it's a button that has a label on the leading side, and on the trailing side there is usually an icon. And where you would use this is, for example, in video playback to choose the speed of the video. Android uses something like this. So let's say we want to implement this into the iOS app as some sort of a material component. So how would we approach this? So this is the design we need. And okay, we get this from a designer, and now we want to implement this in SwiftUI. What we might do at first, we can do something like this that looks relatively simple. So we have a button. That button has a body with the leading and trailing part. Leading and basically the implementation of leading and trailing is not that important. However, as we usually know with design, this is not the only option we want to implement. So the designer can come to us at some later point and say, okay, but now we also want to add an icon. Okay, we think about that, and what do we do? The first thing that comes to mind is, okay, we will add an image as a property on a button, and we will handle this case like that. But then, as we all know, designers usually come up with ways to mess our code, and they might do something like this. Okay, so even though it doesn't make sense for us, maybe it might for them, and they say, okay, now we need to implement a button that has title, subtitle, and caption. Okay, so what do we do? Well, again, we expand our struct for split button and add optional properties for subtitle and caption. And this kind of works, but it's not ideal. Why is it not ideal? Because now we actually support more things than we want to. For example, in this way, we support a case where we have an image and a caption only, but from the design perspective, that's not a valid case, and we don't have that in our design system. So we can make this work by making special initializers that will initialize this only with the valid data. But again, when you try to edit a body of this view, you still need to keep in your head all the cases and variations that you can produce here. So that's not ideal. We can try another approach. What we can do is, I sometimes see in code bases, we can do something like this. So we can define a separate view for every combination we have. But then we have a problem with naming. We need to know how to name these things. And these things are not easily discoverable in your code base most probably, and you will still probably duplicate some parts of the implementations because they are all similar but different. So how can we solve this? So, well, the easiest way is to see how someone else does it. And in this case, since we are using SwiftUI, let's see how SwiftUI solves this problem. Okay. So SwiftUI, if we take a look at the button in SwiftUI, this is how its protocol is defined for the styles. So it has a associated type for a view. It has one function called makeBody and the configuration. Now, what is this configuration? It's basically it contains everything that this button needs. It contains a label. It also has a role, and it has a state whether the button is pressed or not. And how the label is defined is that it has this type alias body never. We will see how we can replicate that. We cannot do that exactly because SwiftUI can do this because it has some private API how to resolve this. But the general idea is that you have some kind of a style and the configuration. Basically, that's how SwiftUI does it. So let's say we want to make a material button, for example. So our own button, we can implement the style protocol, and then we can implement the UI for it in the makeBody function. We can make this nice extension on the button style so that it's easier to instantiate this style. And then how we use this is we say a button, and we say button style, and then we say dot material, and we created our own button. Now the nice thing about this is if you have autocomplete in Xcode, when you tap a dot, you actually see all the styles for a button, so they are more easily discoverable. So now we saw how to do it with a SwiftUI component button. Now let's try to do it. We can maybe try to replicate this with our split button. So can we use the same style as SwiftUI? So let's see. Okay, we will define a protocol, split button style. We will also make makeBody function, and which will return an associated type body, which is some kind of a view. We define the configuration. In our case, we have the is expanded because the split button can be in the expanded state and not expanded state. And we add a label. Now, what is this label? How do we define that never type in SwiftUI? We cannot do it exactly, but we can do something like this. We can say that the body will be any view, basically. And then in the initializer of the configuration, we just wrap the label into the any view. Okay, now we made our configuration. And what else we need to do? We need to somehow propagate that style. So SwiftUI uses environment to propagate its styles. So we need to create an environment for our split button style, and we can use the entry macro to create a style. We give some default style that will be applied if the user did not provide it, any style. And after we do that, the question remains, how do we define the actual split button? Let's see how it's done. We create a split button. We use the is expanded as a binding to change the state, and the label can be any type of view. So basically, the split button is generic over label, similar to how the button was generic over is generic over any label. We create an initializer. We create an environment from which we will get the style. And how the body looks like, we only create a configuration, and then we wrap it into any view and call the style.makeBody. Okay, so just a second. So how do we now create a custom style? So we have a button and the configuration and the protocol. Now we want to create a custom style. To do that, we will create a struct material split button style. We will conform to the split button style protocol. And now we need to implement the make body function. This code is not that important, but basically here we style our component, how it would, however we want to match the material design. And finally, when we now we are done, and how do we use this split button? So we can now use it inside of some view. We can say split button, and for the label we pass in the for example text, and we say that the style is material. And of course, as we did for the button style, we can also do an extension on split button styles to make this nice syntax where we can write dot material. And now what we accomplished is basically a similar API to the SwiftUI's default button. Now there is one thing that's different. If you take a look to the right, the button has some neat initializers. For example, here we don't provide the label directly. We just provide a string, and button knows how to display that. We can do the same thing. We can create an extension on split button and create an initializer inside of the extension, but this is like a conditional where label is equal to text. So when we provide text as a label, we will get this. We can use this initializer instead, so that we inside of it create a text, and this will give us basically a nice API similar to basically the same as SwiftUI has. Okay, so we accomplished something that is similar to SwiftUI, and this is how it looks. But from before, we still didn't answer a question: how do we then support something like this with this new style? And to do that, we use something called composing styles. Basically, the idea is to compose different components so that they work together. So in this case, if we go back for this example, we can treat this title, subtitle, caption as another component in our design system. Because if you think about it, there is a high chance that this same design will be probably used in, for example, a regular button, not just a split button. And how can we do this then? So we can do a similar approach what we did with styles and configuration, just for, let's say we call it vertical container in this case. So vertical container will be, again, generic over three things: so top part, middle part, and bottom part, and those can be any views. They don't need to be only texts. And basically what we do is we do this. We have a similar style protocol like we had for split button. Again, similar configuration, and environment values and an extension on a view, so that we have a nice syntax for declaring styles. And the cool thing about this is that once we create, for example, material vertical container style, and we style it the way the material design dictates, there is this cool thing where if you go back to the split button style, inside of the material split button style implementation, we can actually set the vertical container style to be material. What this allows us is, for example, in the case above, we have a text label. And split button will know how to render the text label with the material style. But if we provide it with a vertical container, and again put the material style, then split button can work with, knows how to work with vertical container basically, and knows how to style it itself. And what we can do is we can do the similar thing what we did before with initializer. We can create another initializer for the vertical container, and then we can just initialize it with title, subtitle, and the caption, for example. So this way, basically what we did is we created a component, we created a style and protocol associated configuration, and then we also, in the end, we create specific custom styles to style the component. And what this gives us, basically it uses the consistent styling as SwiftUI built-in components. It has a clear separation of styling and definition because it's easier to then change one style than when all the styles are mixed inside of one component. It also provides better discoverability because you don't need to know the names of all the different split buttons. You can just write split button and then initialize it with a split button style, and you will get all the styles for that component. And it scales and composes nicely because, as we saw, we can use different labels for the initialization of split button, and if split button knows how to work with all of them if they are defined in its specific style. So for example, for material, we can define the material style for vertical container, and then if we provide vertical container as a label, the split button knows how to draw it. If we don't, then nothing bad will happen. Okay, are there maybe any questions before I go to the last part? Yes?
Wouldn't it make sense to put the material style modifier that you had into the configuration itself as well? Because that way, now of course, when you define or declare a button, the split button, you still have to remember to set the material design. And if that changes over time, you have to do it all over the code. If it's in the configuration, obviously it's only in one place and it's taken from the environment.
Yeah, that's. I think it's. I understand the question correctly, and it's actually solved because if you don't provide style, split button will use the default style that you set in the when you define the environment variable. And if the material is the only style, then it will use that one. So you define one that you use most commonly, and then if you want another style on some place, you need to use the modifier, similar how SwiftUI does it basically. And okay, thanks for question. Anyone else maybe? Okay, so we need to cover one more thing that I did not mention how it's resolved, and it's this problem basically. So how do you use environment inside custom styles? So let's say we want to style the component differently when it is disabled. So in a regular button, you can use the environment for the isEnabled property, and you can read it and then style the component differently whether the button is enabled or disabled. But if you try to do this in our implementation, you will get this runtime warning. It will say that the accessing environment value outside of being installed on a view. This will always read the default value and will not update. Basically, it means you will not read the correct value for the isEnabled. And if you take a closer look, the style is not a view, so SwiftUI doesn't know how to resolve this is-enabled environment or any environment variable, basically. So how do we solve this? If we go back to our implementation of split button, basically the problem is that this style, we have an environment inside of the style defined here, and SwiftUI doesn't know how to set the proper value for example, is-enabled environment. So how do we resolve this? First, we need to update the style protocol a little bit. We need to use something called dynamic property. This is a protocol defined by SwiftUI, and you usually don't need it, but sometimes you do. So what is it? If you take a look at the documentation, it says that it's an interface for a stored variable that updates an external property of a view. This is a somewhat complicated explanation, but the overview is a little bit better. It says that the view gives value to these properties prior to recomputing the view's body. And basically, how dynamic property works. For example, the environment property wrapper also conforms to dynamic property, because what SwiftUI does is before it before it executes your body, it will inject the correct values for every environment variable you have in your view. But it doesn't know that style contains the environment because the style protocol is not marked with dynamic property. Dynamic property works recursively, basically. It checks every dynamic property of a dynamic property. And now, usually, defining the protocol as dynamic property would be enough. Now our environment style has a dynamic property, and it will know how to resolve the environment inside of the material button style. But in this case, it still won't work because this style is a protocol, and SwiftUI only resolves concrete types. So what we need to do, we need to create a view that will hold our concrete style. So we need to create something like a resolved split button style, where we store the view is generic over style, and then the style is stored not as a protocol value, but actually as some concrete style. And then what we need to do is we need to resolve our any style to a concrete style. And how do we do that? We can define a function on the as an extension of a protocol, where we create a resolved split button style and pass it the self. So this uses a Swift feature called opening an existential, where it basically converts the any style to some concrete style. And after we do that, we just need to use this resolved split button style inside of the body, and now SwiftUI will know how to resolve all the environment values or all the other property wrappers that SwiftUI uses. And yeah, that's it. And now we have a complete implementation that mimics the style of SwiftUI, how SwiftUI styles its components. Any questions maybe for this last part? Okay, if there are no more questions, then that's it. Thank you.
Thank you.